polarity means having different sides. For example, this pencil has two different sides, its tip and its tail. Okay, they are different from each other, so it is a polar object. Another polar object would be a cell. In histology, you might have heard that cells are polar. That means that they have two different surfaces. This is the surface area of an epithelial cell with cilia on it, and this is the basal surface of an epithelial cell. Apparently, they are different structurally and functionally. So it is a polar cell. In biochemistry, when we say that something is polar, we refer to unequal distribution of the charge, which is electrons. For example, this is a molecule. Okay, here, since it is polar, electrons are more concentrated into one side of it than the other side. For example, electrons are accumulating here. So we represent that with an arrow pointing toward the electron dense part, okay, and its tail having a positive in it, or by drawing a delta negative and delta positive to represent partial positive and partial negative charges. Okay, why does this happen? Why electrons are not equally distributed throughout this molecule? Because of differences in electronegativities. What is electronegativity? It is the tendency for an atom to attract electrons to it. For example, this is a table of electronegativities of atoms. Fluorine has the highest electronegativity, and the closer you go to it, the higher the electronegativity is. Oxygen and nitrogen also have high electronegativities. And let's go back to here. Let's take an example, which is chlorine gas. Okay, a molecule of Cl and Cl. Obviously, Cl has the same electronegativity as Cl. So the difference in electronegativity will be zero. So electrons will be equal distributed throughout this molecule, and it will be nonpolar. Another example would be CO bond. Going back to the chart or to the table, oxygen has higher electronegativity than carbon. So electrons will go to the oxygen atom, or will be more concentrated in the oxygen atom. So this will carry a partial negative charge, and this will carry a partial positive charge. Okay, I forgot positive in the tip of this arrow. Okay, that's it. So this bond is called a polar bond. Okay, let's put that in a molecule. For example, CO2, carbon dioxide. Okay, carbon dioxide has two polar bonds. Let me change the color. Okay, it has two polar bonds. But does that mean that it is polar molecule? Well, not every polar bond makes a polar molecule. Here, as you can see, the arrows are canceling each other. They are pointing opposite to each other. So the net dipole moment will be zero. And dipole moment is what we use to quantitatively compare a polar object. So, in addition to electronegativity, the structure of a molecule also plays an important role in determining its polarity. Let's take another example, which is H2O, water. Let me change the color. Okay. Oxygen, hydrogen, hydrogen. Okay, it is a bent molecule. It's not straight like this. Okay, going back to the table, oxygen has higher electronegativity than hydrogen. So there would be a partial negative charge on this oxygen and a partial positive charge on this hydrogen. And since the arrows are not canceling each other, they would be drawn like this, there would be a net dipole moment upward. I mean, think of them as vector summation. The net force would be upward. Okay, let's take another example, which is the CH bond. Change the, okay, CH bond. In general, the CH bond is considered nonpolar, and it is considered that the carbon has the same electronegativity of hydrogen, although there is a slight tendency of electrons to go to the carbon since it is slightly more electronegative than hydrogen. Okay, so in molecules of carbon and hydrogen, for example, alkanes, they are considered to be nonpolar. Okay, let's take another example. CCl4. Okay, this is the color. Okay, C with 4 chlorine atoms. Okay, it's obvious that the forces here cancel each other, and there would be no net dipole moment for this molecule. NH3, H here. Okay, it is not like this. It is, the chlorines are not equally have the same angle around the carbon. Here it is different because it has because of hybridization. You should know the structure of a molecule to determine if it is polar or not. Here, the nitrogen is a pyramidal in shape, so a net dipole moment will be toward upward. Okay, since every hydrogen is less electronegative than the nitrogen, the arrows would be pointing this way. Okay, I think this is enough for polarity. Next, we're gonna discuss intermolecular forces, how polarity makes intermolecular forces. At the end of this video, I would like to inform you that this video is part of a video series about water. I've made a complimentary PDF for the whole series. It's great to review what we discussed here and relate the topics of different videos together. It is completely free. You can find the link in the description below. Thank you for watching and good luck in your study.